All right, students, here we are on Lesson 9 of Unit 4, Algebra 1, Illustrative Mathematics by Imagine Learning. And we're going to be talking about comparing graphs. Go ahead and grab that highlighter, and let's compare graphs of functions to learn about the situations that they represent. Number 9.1 is the population growth. This shows the population of Baltimore. Notice Baltimore is the solid line right here. And then comparing it to the population of Cleveland, which is the dashed line right here. We're going to be looking on an interval. First, it says estimate B of 1930 and explain what it means in this situation. And so 1930 is this input right here. We follow it up, and it wants Baltimore, which is the solid line. And so then we just look over at the output, B of 1930 equals 800,000. And this population is in, I guess it's being given to us as just hundreds of thousands already. Okay, now it says to explain what it means in that situation. And we would say in 1930, the population was 800,000. Sorry, the population of Baltimore. Okay. Here are pairs of statements about the two populations. In each pair, which statement is true? Be prepared to explain. So is Baltimore in the year 2000 greater than Cleveland in the year 2000? Let's go look. So in the year 2000, we've got here is Cleveland and here is Baltimore. So which one is greater? Baltimore is greater. And so it would actually be this statement here. Baltimore, which is the solid line, is above Cleveland at that point. Next is Baltimore in the year 1900 equal to Cleveland in 1900. So if we look back here at the beginning of 1900, these two are not equal. So no, it's not that guy. Is Baltimore above Cleveland? Yes. Baltimore is above Cleveland again at that point. Are the two cities' populations ever the same? If so, when? So if you notice any point of intersection of the two lines, somewhere around here, these points of intersection are when the two populations were the same. So we could say around 1911, and then, I don't know, 590,000. And over here, I'm going to say that that's around 1944. I don't know, 1943, something like that. And that's around 900,000. So again, we're just estimating because the graph is not landing on a corner, right? And so when it says, are these the same? If so, when? We would say in 1911 and in 1944. And again, those are estimates. If you had slightly different numbers than those, I'm sure it's fine. The next scenario it talks about is percentage of homes that have a landline. Do you still have a landline in your house, or have you fully switched to cell phones as well? So H of T is the percentage of homes that have a landline. And so I'm going to highlight this. Oops, that's not highlighter. I'm going to highlight this landline. And that's this solid line right here. Notice that landlines are decreasing in households. And then I'm going to highlight the cell phones only. And notice it's increasing in households. And so estimate H of 2006 and C of 2006. So H of 2006 is the landline one. So that's up here. What do you think that looks like? What do you think? Like 83, 84, somewhere around there. C of 2006 is how many people had cell phone only in the household at that time? What would you call that? Like, I don't know, 18. And so what this means is explain what each of this means. 83% of households had landline in their home. And then 18% of households had cell phone. And then the key part of this is that it was in 2006. That's where this part comes in. All right. So in other words, we state that our output was this when our input was this. And this time our output was this when our input was 2006. Okay. What is the approximate solution when the output for cell phones was 20? And so for some reason, the output ones are always ones that get students a little bit more. So if I follow this along to here, how many of you were born in this year? Output, what year? Would have been 2008, when 20% of households had cell phone only. And that was in 2008. Determine if each of the equations is true. Be prepared to explain how you know. Is 2011, are they equal? So if I look here at 2011, they were not. In 2015, were they equal? Yes. And this is, how do we know they're equal? They are equal when the graph intersects. Where they touch, where they cross over. Between 2004 and 2015, did the percentage of homes with landlines decrease at the same rate in which the percentage of cell phones only increased? Explain or show your reasoning. So this is where we're going to need a starting value. And the starting value is going to be on the interval 2004. And then we want the ending values in 2015. So we want 2004, comma something, and 2015, comma something. And then we want the starting, let me change colors here. We want the starting in 2004, and we want the ending in 2015. So we can calculate those average rate of change and see which one is greater. Sorry, we're doing an increase and a decrease, but we're basically looking at the absolute value. So starting in 2004 and ending in 2004, let's call this one over here landlines, which is our H of T. So if I look up here at the landline, we started in 2004 at around 95. 90 would be right in the middle. 90 would be in the middle, so I'm going to call that 95. And then 2015, we'll call that 50. And so since they're ending at 2015, where they're both the same, we already know that that's going to be also 50. Let's go get the starting for cell phones. In 2004. If this is 10, I'd say that's at like 5. That's like halfway. So now we're going to do the difference of the outputs over the difference of the inputs. The change in Y over the change in X, or F of B minus F of A the difference of the outputs over the difference of the inputs. This is our function notation for average rate of change. So we're going to go y minus y over x minus x. And then we're going to go do the same thing for blue. We're going to go y minus y over x minus x. We can call this average rate of change or just M. And so grab a calculator. That's going to be negative 45 over 11. So I'm getting that average rate of change is negative 4.09 approximately. And that's for landline. That's the decrease rate of landlines in households. And then over here, we're going to get a positive number, 45, because they're increasing, over 11. And we get a positive 4.09. So notice that the rate of increase and the rate of decrease is the same. Is the same on that interval. And that's from 2004 to 2015. This is part of the continuing for the Are You Ready for More? So feel free to work on those if you'd like to. Finally, we're on 9.3, the number of people who watched a TV episode on the function of this show's episode number. Here are 3 graphs of the functions A, B, and C representing the different shows. Episode numbers are along this axis and audience in millions. Notice as more episodes are going, the audience grew in show A. As more episodes are going, the audience went down and then sort of flattened out in show B. And then notice in show C, as the episode numbers increased, it was kind of flat, then it had a big jump, and then it went back down again. Match each description with a graph that could represent the situation. This show has a good core audience. They had a guest star on the 5th episode that brought in some viewers. And so however you want to match these, but this one, which one does it go to? Notice that peak for the guest that came on episode 5. So this one is called show C. This show is one of the most popular shows and its audience keeps increasing. And so this one right here with an increase, and we'd call that show A. This show has a small audience. But it's improving, so more people are noticing. This show started out huge, and even though it feels like it crashed, it still has more viewers than another show. And so that would be show B. It says one of the descriptions has no corresponding graph, so that's number C. And let's go find one more highlight color. All right, which is greatest? A of 7, B of 7, C of 7? So when I go out to episode 7 here, if I follow this up, it looks like it's at 1.75. Up here, episode 7 is at 4 or so. Here, episode 7 is at like 3.5, or maybe not even, maybe it's more like 3 or 3.1. Either way, episode 7 of show B is definitely the highest. Okay, and by the way, you may not have noticed the scales on these before until we went to actually answer that question. And so notice that the graphs could have been misleading before. If we thought we were comparing apples to apples, if we thought all of the graphs were on the same scale, it can be very misleading. And so truly, this one has the greatest number of viewers. Over there on the side, if we see how that one is scaled. We want to be careful with scaling before we make any judgments. Sketch the graph of the viewership of the 4th TV show that didn't have a matching graph. And so this show has a small audience, but it's improving, so more people are noticing. And so we could just actually just go like skip 1, skip 2, and we could literally just go like, something like that. Okay, finally, here's some input-output quick questions for you. F of 2 or G or 2, which value of the function is greater? So F of 2 or G of 2, good job. F of 4 or G of 4, neither. They are equal. F of 6 or G of 6, F of 8 or G of 8. Is there a value at which the equations are equal? Yes, right here at 4, 7 is where they intersect and are equal. And here at 9, what is that, 5.8? They're also equal. Identify at least 2 values of which the inequality f of x is less than g of x. So we're going to be looking for all these areas where the f function is below the g function. So we can't choose that little upper arch. We can choose anything up until 4 and anything after 9. So we could say, for example, f of 1, or we could say f of 2, or we could say f of 3, because all those are before 4 or in that lower region. And then what could we also say? We could say f of 10 or f of 11. Any of those would be acceptable answers. How'd you do? Go ahead and highlight the summary. Read over what you should have understood from today's lesson.